Number 34. How many electrons must be gained or lost by each element to achieve a noble gas configuration of electrons? So you're given 4 elements, and it's asking you, for instance, for cesium, how many electrons does cesium need to gain or lose in order to achieve a noble gas configuration of electrons? Now, for cesium to achieve a noble gas configuration of electrons, that's just a fancy way of saying for it to have the same number of electrons. So let me just underline that. So that means, to have the same number of electrons as a noble gas. So same number of electrons as a noble gas. So I'll highlight that as a noble gas. So look at cesium on the periodic table. You can find it over here. It's element 55. Okay. And then look at the noble gases on the right-hand side. There they are. That's the noble gas column, group 8A, or group 18, depending on which numbering scheme you're using. Okay, now which noble gas element is closest to cesium? Okay, cesium's element 55. The next noble gas, if you proceed forward, you have to go 55, 56, and then drop down here, go through all these guys, and then go back up, 72, 73, all the way up to 86. Okay, that would that would be a lot of electrons to gain. Cesium's got 55 electrons in the balanced atom. Radon has 86. So that would have to gain 33 electrons to be like radon. Okay, but then xenon is element number 54, the previous noble gas, and all cesium would have to do would be to lose 1 electron to be like xenon. So cesium's element 55, xenon is element 54. So this guy has 55 electrons, xenon's got 54. So cesium's just got to lose 1 to be like xenon. So here, A. So cesium, we'll just say it loses 1 electron, and that makes it like xenon. Okay, let's do barium. Barium is next to cesium. Okay, there's barium right there, element 56. Now we got the same issue. Barium could gain lots of electrons to be like radon, or it could just lose 2 to be like xenon again. So barium, it's going to lose 2 electrons if it forms an ion. That's what happens when something forms an ion. It loses or gains electrons to be like a noble gas. And barium, if it forms an ion, it would simply lose 2 electrons to be like xenon. Now, if it did that, you would write, barium plus 2, and cesium would be cesium plus 1. Okay, if you wanted to write the ion symbol, but it's not asking us to do that. So I'm going to erase this right here. Okay, it just asks us for how many electrons are gained or lost. Okay, the next one is selenium. Selenium is a nonmetal, so you'll find selenium over here. It's in the oxygen column, so group 6A. So here's selenium, and you could lose a bunch of electrons to be like argon, or you could simply gain 2 to be like krypton. This is element 34, and this is element 36. So gain 2 electrons to be like krypton. So selenium, we'll put gain 2 electrons, and that makes it like krypton. And if a selenium atom did that, it would have a -2 charge. Right? I'll erase that. And then finally, D is aluminum. Aluminum's a metal, So, you know, metals tend to lose electrons. Hopefully you're seeing this trend. And nonmetals tend to gain electrons. So aluminum's a metal. We would expect it would lose electrons. So there's aluminum right there. Okay, it's element 13. Now it could gain 1, 2, 3, 4, 5 electrons to be like argon, which would make it a -5 charged ion, or it could lose 1, 2, 3 to be like neon. Okay, and that's what it would do, of course. So aluminum, it would lose 3 electrons, and that would make it like neon.